Sahil. My teacher has given me a project to make a parallelogram with this shape. It's such a weird shape, and you cannot even use a protractor nor a compass. And you can only use a pencil and a scale. I have no idea how to do it. Do you have a solution?
Well, I obviously do have a solution. Go watch Maths with Madhuri.
Yeah.
Hello everyone. Do you know we can solve these children's problem using midpoint theorem? Yes, we can do that. It's a very important theorem in grade 9 and it has got lots of useful applications. So let's see what does this theorem states and how to prove it. Do watch the complete video because at the end we will use this theorem, this midpoint theorem, to solve these children's problem. Right? So now let's get started. Let's see what does this midpoint theorem states. So it states that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side and is equal to half of it. Now what does this mean? So I'll explain you. Let's say there is a triangle ABC, okay, and the midpoints of any two sides of the triangle is given. So let's take AB and AC. And the midpoints are D and E. Okay, let's say D is the midpoint of AB and E is the midpoint of AC. Right? So if D is the midpoint of AB, I can say that AD is equal to DB. And if E is the midpoint of AC, I can say that AE is equal to EC. Right? Now, if these two conditions are satisfied, then the line segment joining these two midpoints, you can see here, the line segment joining the midpoints of any two sides of a triangle is parallel to the third side. So DE will be parallel to the third side. Now here BC is your third side because AB and AC you have taken already, right? So BC is your third side. So DE will be parallel to BC and it will be equal to half of it. So DE will be equal to half of BC. I hope it is clear to everyone now. I'll repeat once again. In a triangle, the line segment joining the midpoints of any two sides of a triangle will be parallel to the third side and will be equal to half of it. I'll explain you using one more different figure. Let's say here PQR is a triangle, right? Let's say M is the midpoint of PR and N is the midpoint of QR, right? So this is the line segment joining the midpoints of these two sides of the triangle, right? So this line MN will be parallel to PQ. Okay, MN will be parallel to PQ. Also, MN will be equal to half of PQ, right? So I hope it is clear to everyone. Now let's prove it. Let's prove that why here DE will be equal to half of BC. Also DE will be parallel to BC. How this is true? So first we have to write down given and then to prove, right? So given we have that ABC is a triangle and D and E are midpoints of AB and AC. Okay, this much is given to you. Now what do you have to prove? So I have written here already that DE is parallel to BC and DE is equal to half of BC. So these two things you have to prove, right? Now, before we start proving it, let's see how to, start your thought process, right? So here my first aim is I have to show that DE is parallel to BC, right? Now how you will show that? So think about the parallel lines like what you have studied in your previous classes. So let's say there are two lines, right? And if you want to prove that these two lines are parallel, so how do you prove that? You draw a transversal, right? And here, let's say these two angles are corresponding angles, right? So if these two corresponding angles are equal, then what do we conclude? We conclude that line L is parallel to line M, isn't it? Similarly, if we talk about these two angles, right? These two angles are which pair? They are alternate angles. So if alternate angles are equal, we can conclude that L is parallel to M, right? Also, you have one more option, that if you show that the sum of these two angles is 180 degree, they are co-interior angles, right? So if their sum is 180 degree, I can conclude that L is parallel to M, right? So this is what you have studied in your previous classes. So can you use this concept here to show that DE is parallel to BC, right? Here you can take DE and BC as any two lines. Let me remove these arrow symbols because this is not given. This we have to show, right? Right now DE is not parallel to BE. This I have to show that they are parallel, right? So if I take these two as any random lines, then DB will act as a transversal, right? So these two angles are corresponding angles, right? So if I show that these two angles are equal, then I can conclude that DE is parallel to BC, right? But or you can show like this angle. This angle plus this angle is 180. Then also you can conclude that DE is parallel to BC. But right now the given information is not enough because I don't have any information regarding the angles here, right? So I can't show that, the sum of these two angles is 180 or these two angles are equal. So I can't use this concept here. Alright, I can't use this concept here. So I have to think of something else, right? Now, what else you can think? Like when you think about parallel lines, don't you think that parallelogram comes to your mind, right? So here, if I show that any quadrilateral is a parallelogram, then my job will be easier, right? But right now, I have only one quadrilateral here, which is DECB. It doesn't look like parallelogram, right? So I can't show that it's a parallelogram. So after thinking so much, one thing is clear, that whatever information is given here is not enough to show that DE is parallel to BC, right? So I have to construct something. Okay, so you have to construct here a quadrilateral and you will prove that that quadrilateral is a parallelogram. So what you will construct is from C draw a line parallel to BA. Okay, draw a line parallel to BA and produce DE so that it meets F. This also draw a dotted line. Always remember, we do construction using a dotted line. Okay, so here we can easily make out that these dotted lines are the construction part. Alright, so now here you can see that BCFD, this is a quadrilateral, right? Now if I show that BCFD is a parallelogram, if I show BCFD is a parallelogram, then we know that in a parallelogram the opposite sides are parallel and equal, right? So I can say that DF will be parallel to BC. So DE will be parallel to BC. So this is what I have to prove here, right? I have to show what? That DE is parallel to BC, right? So now my aim is to show that this quadrilateral BCFD, this is a parallelogram. Okay. So now how do we show that a quadrilateral is a parallelogram? If you show that one pair of opposite sides are equal and parallel, then it becomes a parallelogram, right? So here in quadrilateral BCFD, BD is parallel to CF, right? Because we constructed, right? We already constructed, no? We drew CF parallel to BA. So these two opposite sides are already parallel. Now if I show that these two sides are equal to each other, then this will be a parallelogram, right? Now how to show that BD is equal to CF? Alright, so now you have to think how to show BD is equal to CF. Now do you have any information about BD? Yes, BD is equal to AD, correct? BD is equal to DA. So I have to show that BD is equal to CF. Since BD is equal to DA, I can also show that DA is equal to CF, right? If I show that these two are equal to each other, I can conclude that CF is equal to BD. And then this will be a parallelogram, right? So now my aim is to show that AD is equal to CF. Okay, so it's a continuous chain kind of thing. So now how do you prove that DA is equal to CF? Basically, I have to show that two sides are equal, right? So whenever you have to show like two sides are equal or two angles are equal, which concept do you use? We use congruent triangle concept, right? So here, since DA is a part of triangle DAE and CF is a part of triangle CFE, so if we show that these two triangles are congruent, then we can say that DA is equal to CF, because we know if two triangles are congruent, then their corresponding parts will be equal, right? So if these two triangles are congruent, then DA will be equal to CF. And since DA is equal to BD, right? DA is equal to BD and DA is equal to CF, so I can say these two sides are also equal to each other. So this becomes a parallelogram, right? So I can say that DE will be parallel to BC. So first part is done. So let's do first part. Let's write it down. Then we'll focus on the second part. Alright. So first you have to write down what is construction. So here the construction is draw CF parallel to BA and produce DE to F. Now proof. So first step will be that you will show these two triangles are congruent. Okay. So take triangle AED and triangle CEF. In these two triangles you have to prove that three parts of these two triangles are equal to each other, right? That's how we prove the two triangles are congruent. So here, can I say that angle 1 is equal to angle 2? Can I say that? Yes, angle 1 is equal to angle 2. Why are they equal? They are vertically opposite angles. Right, now here CF is parallel to BA, right? These two lines are parallel, correct? And this will act as a transversal, right? These two lines are parallel, you can check. These two lines are parallel and this will act as this line will act as a transversal. So what about 3 and 4? What can you comment about angle 3 and 4? Aren't they alternate interior angles, right? So angle 3 will be equal to angle 4. Reason? Alternate interior angles. Alright. Now you need one more. You have to show one more part in these two triangles are equal. So in case if you get confused, just go back to given. In given, whatever you have written from there, you will get some kind of hint. Okay. So it says that D and E are midpoints of AB and AC. So you can check out here, AE is equal to EC, right? Because E is the midpoint of AC. So here, AE is equal to EC. Reason? It's given. Alright. So let's see. Whatever angles and sides we have taken are in the proper order or not. So let's pick one triangle. You can pick this triangle or this triangle, up to you. So let's pick this triangle. In this triangle we have taken angle 3, we have taken AE and we have taken angle 1, right? So it follows angle side angle sequence. So the two triangles are congruent by ASA. So write down triangle AED is congruent to triangle CEF by angle side angle congruency, right? So this implies can I say that AD is equal to CF, right? By CPCTC. So what is CPCTC? Corresponding parts of congruent triangles are congruent, right? So now what about AD? AD is also equal to DB, correct? Also AD is equal to DB. So from 1 and this is also given. So from 1 and 2, what can you conclude? AD is equal to CF and AD is also equal to BD. So can I say that BD will be equal to CF, right? So from 1 and 2, BD will be equal to CF. Alright. So now in this quadrilateral, BCFD, in this quadrilateral, BD is equal to CF. Just now we proved it, right? BD is parallel to CF by construction. So in a quadrilateral, one pair of opposite sides are equal and parallel. So it is a parallelogram, right? So you can write down from 1 and 2, BD is equal to CF. Then you can write down also BD is parallel to CF. Reason? By construction. Okay. So this implies BCFD is a parallelogram. Alright. Now if BCFD is a parallelogram, then their opposite sides will be equal and parallel, right? So therefore, DF will be parallel to BC and DF will be equal to BC, right? Now, if I say that DF is parallel to BC, can I say that DE is parallel to BC? Yes, of course, right? Because DE is a part of DF, right? So, since DF is parallel to BC, this implies DE is parallel to BC. So, we have proved one part of the theorem. You can see that here we have proved this part, right? Now, let's focus on this part. Now, here DF is equal to BC, right? So, what do I have to show? I have to show that DE is equal to half of BC. So, if I show that DE is equal to EF, so don't you think that DE will be equal to half of BC? Because DF and BC are equal, right? So, half of DF is how much? Half of DF will be DE, right? So, if I show that DE is equal to EF, then DE will be equal to half of BC, right? Now, do you think that DE is equal to EF? Do you think, are they equal? Yes, they are equal. Why? Because we already proved here, no, that triangle ADE and triangle CEF, these two triangles are congruent, right? So, DE is a part of this triangle and EF is a part of this triangle, right? So, since these two triangles are congruent, their corresponding parts will be equal, right? So, here DE is equal to EF, right? So, now here DF, I can break it down. I can write DF as DE plus EF is equal to BC, right? Now, can I replace EF? Can I replace EF with DE? Yes, I can replace because they are equal, right? Now, why I am replacing EF with DE? Because I need DE. I have to show that DE is equal to half of BC, right? So, I will replace EF with DE. So, here I will replace EF with DE, right? Now, you have to write down the reason also, like why you are replacing, right? So, you can write down, since triangle AED is congruent to triangle CEF. right? This implies DE will be equal to EF by CPCTC, right? So you have to give this reason. Now, can I write DE plus DE as 2DE? Now from here, DE will be equal to half of BC. So this is what we have to prove, right? That DE is half of BC. So this is all about midpoint theorem. So let's see once again like what we did and what the theorem says. So the theorem says that in any triangle, if there is a line segment which joins the midpoints of any two sides of a triangle. So let's say this is the midpoint of AB and E is the midpoint of AC, right? So this is the line segment joining midpoints of AB and AC. Then DE will be parallel to BC and DE will be equal to half of BC, right? So this is your midpoint theorem. Now how we proved it? So we did construction. We drew CF parallel to BA and we produced DE to F, and then we got this quadrilateral, right? And in this quadrilateral only BD was parallel to CF, right? So we showed that BD is equal to CF also. So we showed that this is a parallelogram, right? We showed this is a parallelogram and then DE became parallel to BC, right? So how did we show that CF is equal to BD? Now for that, we first showed that these two triangles are congruent. So CF will be equal to DA and DA is already equal to BD. So ultimately BD will be equal to CF, right? So we showed that these two are equal. So this became a parallelogram and the first part was done, that DA is parallel to BC. Now the second part. Now since this is a parallelogram, so DF will be equal to BC, right? So half of DF, which is DE, will be equal to, so D will be equal to half of BC, right? So why here DE is equal to EF? Because we showed that these two triangles are congruent. That's why DE is equal to EF, right? So that's how we proved this midpoint theorem. Now let's use this theorem to solve these children's problem. So here these children have got a quadrilateral shaped cardboard and they have to cut out a parallelogram out of it without using protractor and compass. So let's see how midpoint theorem helps in that, right? So for that, the first step is you have to take a scale and find out the midpoints of each side of this quadrilateral. So let's say D is the midpoint of AB, E is the midpoint of AD, F is the midpoint of CD and G is the midpoint of BC, right? So now if you join these midpoints, the shape which you will get, the quadrilateral which you will get, this will be a parallelogram, right? Here quadrilateral DEFG, this is a parallelogram. Now let's see how it's a parallelogram. So for that you have to join BD. Okay, so join BD, yes. So now in triangle BDA, what do you observe in this triangle? In triangle BDA, D is the midpoint of AB and E is the midpoint of AD, right? Now what does the midpoint theorem states? If the midpoint of two sides of a triangle is given, then the line segment joining those midpoints will be parallel to the third side, which is BD, and DE will be equal to half of BD, right? So here from the midpoint theorem we can conclude that DE is parallel to BD and DE is equal to half of BD, right? Now similarly in the other triangle, in triangle CBD, what do you observe? That G is the midpoint of BC and F is the midpoint of CD. So from midpoint theorem, GF will be parallel to BD, right? GF will be parallel to BD and GF will be equal to half of BD, right? Now from first and second, what can you conclude? So if you see carefully, we have shown that DE is parallel to BD and GF is also parallel to BD, right? These two lines are parallel to the same line. So can we say that these two lines are equal, these two lines are parallel to each other, right? So from first and second we can conclude that DE is parallel to GF. Also we have shown that DE is equal to half of BD and GF is equal to half of BD. So since two lines are equal to half of the same line, then we can conclude that DE is equal to GF, right? So from these two, what can you conclude? That DGFE is a parallelogram, right? Because if you show that any one pair of opposite sides are equal and parallel, then it becomes a parallelogram, right? So here we have shown that DE and GF, they are parallel and equal to each other, right? So this cutout will be a parallelogram. So you can see that how easily by using midpoint theorem we have drawn a parallelogram without using any compass and protractor. So I hope you have understood this theorem. It's a very important theorem, so do practice it. So that's it for today. See you very soon with few more interesting topics. Until then, goodbye, take care.